All right, today we're going to start with lesson 98, and the first thing we're going to cover is the distance between 2 points. You have to graph these 2 points, and yes, you have to use graph paper. It won't be counted correct. That means you'll have to scan your graph paper in as well for me to see. So the first example, 98.1 on page 413 says to find the distance between the points whose coordinates are 4, 2, and -3, -2. So graph those 2 points. 1, 2, 3, 4, 1, 2. -1, 2, 3, down 2. All right, now make a right triangle out of those 2 points. So I'm going to draw this, that's the hypotenuse, come straight down and straight across so that we have a right triangle. Now what we learned in 97 was the Pythagorean theorem. Just as a refresher, c squared is equal to a squared plus b squared. And remember, c is the hypotenuse and it's always across from the right angle. So c is what we're looking for, is the distance between here and here. So we can count the blocks here. 1, 2, 3, 4. That length is 4. 1, 2, 3, 4, 5, 6, 7. This length is 7. So c is what we're looking for. So c squared will be equal to, it doesn't matter which one is a or b. This would be 4 squared plus 7 squared. So c squared is equal to 16 plus 49. Remember, you can't just take the square root of these. You have to add them first. C squared is equal to 6 and 9 is 15. 2 and 4 is 65. And then we take the square root of both sides. But remember, because this is a distance between 2 points, it's not going to be a negative number. We don't have to put plus or minus because there is no negative distance. So when we take the square root of c squared, we get c equals, take the square root of this side, we get square root of 65. And nothing goes into 65, that's a perfect square, so we're finished. So the distance between this point and this point is the square root of 65. We just leave it like that. All right, the next example is also on page 413, 98.2. Find the distance between 3, -4, and -5, 2. All right, again, graph the 2 points. 1, 2, 3, 1, 2, 3, 4. -1, 2, 3, 4, 5, +2. Draw the right triangle, so I'm going to come straight down, straight across. We're finding this distance, so I'm going to label it C. And now we're going to count the length. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8. And we set up Pythagorean theorem. C squared equals a squared plus b squared. We're looking for c squared. So that will be 6 squared plus 8 squared. So c squared is equal to 36 plus 64. C squared is equal to 100. And then we take the square root of c squared is c. The square root of 100 is 10. So the distance between these 2 points is 10. Okay, moving on to the slope formula. The slope of a line is what I like to refer to as the steepness of the line. The slope is always equal to rise over run. It's the distance going up or down divided by the distance going left to right. The rise is how much it changes going up or down. The run is how much it changes going left to right. All right, so the formula, and we let slope be abbreviated by M. I don't have any idea why they used M for slope, but they did. It's always M in whatever math textbook you would use. The formula is y2, that is not y squared, minus y1 over x2 minus x1. Now, what that refers to is we're going to have 2 points, point 1 and point 2. We'll find the slope between 2 points. So this will be x1, y1. This will be x2, y2. So the second y value goes right here. The first y value goes here. The second x value goes here, and the first x value goes here. It doesn't matter if you start with this as point 2 and this is point 1, but what is very important is that if this is x1, this has to be y1. This can't be x1 and y2. If this is x1, this must be y1. If this is x2, this has to be y2. So if you look on page 415, it says find the slope of the line, not the distance between the 2 points, but the slope of the line that passes through -3, 4 and 5, -2. All right, I'm going to pick this as point 1 and this as point 2. So m equals, I'm going to write the formula again until I get used to it, and I'll plug into that. So because this is point 2, this is y2, x2, x1, y1. So y2 is -2 minus, because it's a minus in the formula, y1 is 4. Divided by x2, which is 5, minus x1, which is -3. So don't forget, it's minus a minus. Okay. So m will be equal to -6 over 5 plus 3, which is -6 over 8, and always reduce it to lowest terms. So that would be -3/4. So the slope of that line is -3/4. Okay, the last example in this lesson is actually to find the slope between those same 2 points. So between -3, 4 and 5, -2, only this time they want this to be point 2 and this to be point 1. So this will be x2, y2. This will be x1, y1. And the reason they're doing this is they want us to understand that it doesn't matter which point you start on. You will still get the same slope regardless. So regardless of which point you use for point 1 and point 2, the slope will come out to be the same. So we're going to use the formula m equals y2 minus y1 over x2 minus x1. And I'm going to plug these numbers in. So y2 is 4 minus y1 is -2. So it's 4 minus a -2 divided by x2 is -3 minus x1. Sorry about that. x1 is 5. So m will simplify to 4 minus a -2 is 4 plus 2 over -3 minus 5 is -8. So that's 6 over -8, which reduces to -3 over 4. So you see, we got -3 over 4 here and -3 over 4 here. So you do get the same answer for the slope between 2 points regardless of which point you start and end on. All right, so the answers were posted in yesterday's assignment. You can go in there and grade that one as well before you submit your graded assignment to me through Canvas. If you have any questions, you can always email me, or you can call my cell phone number, which is 575-420-1738. I'll answer questions either way, email or this way. All right, guys, I look forward to getting your homework assignments and working through this semester. Thank you.